In this video, I will provide a lot of examples on the laws of roots. If you don't feel comfortable with the basics of roots, feel free to watch my videos called Intro to Roots and Laws of Roots. Feel free to pause the video after each example and try it yourself. Let's start with the square root of 18 multiplied by the square root of 2. Using the multiplication rule for roots, we can write the product of 18 times 2 under one root, which gives us 36. The square root of 36 is 6, and we're done with this problem. Let's look at the third root of 7 in parentheses. Raised to the third power. For this example, we can use the rule which says that when taking a root of a number and then raising that to the same power as the root's index, we end up at the number with which we started under the root. So in our example, when we are taking the third root of 7 and then raise that to the same power as the root index, which is 3, we end up at that number we started with under the root, which is 7. Let's look at the fifth root of x raised to the power of 5. Do you remember how we had the rule for n is even and n is odd in the last video about rules for roots? In this example, n is odd, so the solution is x. Let's choose an example with an even index. The 14th root of x raised to the power of 14. According to the rule for even indexes, we get the absolute value of x as our solution. Let's look at the third root of 24. How can we simplify this? In problems like this, always ask yourself, how can you factor 24 so that one of the factors is a perfect power? The answer is 8, because 2 raised to the third power is 8. So let's write the 24 as 8 times 3. Then we get the third power of 8 times the third power of 3. The third power of 8 is a perfect third power, which becomes 2. And the leftover factor 3 remains as the third root of 3. So the solution is 2 times the third root of 3. Let's look at the square root of 8. Feel free to pause the video and try this simple example on your own. The square root of 8 is equal to the square root of 2 times 4. Which is equal to the square root of 2 times the square root of 4. Two is not a perfect square, so we leave the square root of 2 and the square root of 4 is 2. So we get 2 times the square root of 2 and we are done with this problem. Let's look at the square root of 50x cubed. Again, how can we factor the expression under the root with the goal to find the largest perfect powers possible? Let's try to write the expression under the root as 25 times 2 times x squared times x. After using the multiplication law for roots, we get the square root of 25 times the square root of 2 times the square root of x squared times the square root of x. The square root of 25 is 5 and the square root of x squared is x. So we get 5x. Two and x does not make a perfect square, so we leave them as the square root of 2 and the square root of x. Because of the multiplication law for roots, we can write the square root of 2 multiplied with the square root of x as the square root of 2x, and we're done with this problem. Just to thorough, I must say that when you simplify a radical and when you define the square root to be positive, it's important that both, in our example, the square root of 50x cubed and 5x times the square root of 2x are both defined only for non-negative values of x. So always make sure that you check this when simplifying roots. What about this example, the fourth root of 48? We can write the 48 as 16 multiplied by 3. Sixteen is a perfect fourth power and the 3 is a leftover factor. So we get the fourth root of 16 times the fourth root of 3. Which is the 2 times the fourth root of 3. Let's look at an example where we can use what we'll call the n is even rule for roots again. The seventh root of 5x where 5x is in parentheses, and then raise the 5x to the power of 7. The n is even rule says we get the absolute value of 5x as our solution. How can we simplify the absolute value of 5x further? The x can be positive or negative. It depends on what value you put in for x, but the 5 stays 5. So we can write 5 times the absolute value of x as our solution. The third root of 40x raised to the power of 4. How can we find the largest cube factor? That's simple. The largest cube factor is 8x cubed. And the leftover factor is 5x. With the multiplication rule for roots, we can write this as the third root of 8x cubed times the third root of 5x. The third root of 8x cubed is 2x, because 2x cubed is 8x cubed. And the third root of 5x we'll leave as is, because 5x is not a perfect cube. What about the third root of negative 56x raised to the power of 6? Feel free to pause the video and try this on your own. Again, first try to find the largest cube factor, which is negative 8x cubed. Also, we have x cubed. And the leftover factor is 7. So we get the third root of negative 8x cubed times the third root of x cubed times the third root of 7 which is equal to negative 2x times x times the third root of 7 which is finally negative 2x squared times the third root of 7. Let's look at an example where we combine radicals. 2 times the square root of 32 plus 3 times the square root of 18. When we see problems like this the first time, we don't know what to do. The first step is always to try to write the number under the root in a way where you can partially take the root. So let's try to write the 32 as 16 times 2 and the 18 as 9 times 2. Which looks very good because we have the number 2 twice. You will see later that this was a good choice to write the 32 as 16 times 2 and to write the 18 as 9 times 2. Let's use the multiplication law for roots and write 2 times the square root of 16 times the square root of 2 plus 3 times the square root of 9 times the square root of 2. The square root of 16 is 4. And the square root of 9 is 3. Two times 4 is 8. And 3 times 3 is 9. So we get 8 times the square root of 2 plus 9 times the square root of 2. Now finally we can combine these two expressions because they are like terms. And we get 17 times the square root of 2 and we're done with this problem. For beginners this may look difficult, but when you do some exercises they become very simple. So do your exercises and enjoy the learning process. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning everyone.